Hello everyone. For today's tutorial, I'm going to be talking about sequence and series. Now for sequence and series, we have two types. We have the arithmetic progression and the geometric progression. But my main focus for this particular tutorial is going to be on arithmetic progression. Now I'm going to first of all start by explaining sequence. Now, most times when we are given a range of numbers or a group of numbers, we do notice that these numbers follow a particular pattern. For instance, when I'm given 2, 4, 6, 8, 10, you notice that these numbers, they increase by 2. This is 2 here, and now I have 2 plus 2 to give me 4. I have 4 plus 2 to give me 6. 6 plus 2 to give me 8. 8 plus another 2 to give me 10. And so on and so forth. Now, whenever a number or a range of number or a group of numbers follows a particular pattern, maybe they increase or maybe decrease, it could be anything, you just know that this is a sequence of numbers. You call it a sequence. And now when you are given a sequence of numbers, each of the digits in the sequence is called a term. So 2 here is a term, 4 here is a term, 6 here is a term, the same as 8 and also 10 and the subsequent numbers. Now I'm going to move over to the arithmetic progression. So the arithmetic progression is a sequence of numbers in which the term increase either by adding or subtracting a constant number. For instance, this sequence here is in arithmetic progression because, as you can see, each of the digits, 2 is added to them to get the next one. So when a number is increasing or decreasing, either by adding or subtracting another value, a constant value, you can say that it is in arithmetic progression. Now, when you are given an arithmetic progression, let's say 2, 5, 8, 11, and so on, you can see that these ones, for this particular one, that 3 is added to the previous value to get the next one. Now, the first term here, which is the first number that you are given, the first number that you're given is what we call the first term. And it is represented by A. And now that constant number that you keep adding or that you keep subtracting to get the next one is what we call the common difference. And it is denoted by a small letter D. So for instance, in this particular sequence, the common difference here is 3. And you can get this common difference by subtracting the first term from the second term. This here is the first term, this here is the second term. So when you want to get the common difference for this particular sequence, all you have to do is 5 minus 2 and you're getting 3. So 3 here is your common difference. And then for this one, you're going to be having 4 minus 2, which is equal to 2. So 2 here is the common difference. Now, mind you, even if the first term is greater than the second term, to get the common difference, you still have to subtract that first term from the second term. The only thing there is that you're going to be getting a negative number instead of a positive number. Now, let me give you an instance. If I have minus 2, minus 1, 0, 1, 2. Now, as you can see in this particular sequence, minus 1 here is greater. Okay, sorry, no, let me do it this other way. Let's assume that we have 2, 1, 0, minus 1, minus 2. Now, if you look at this sequence here, you're going to notice that 1 here is smaller than 2 and 0 here is smaller than 1. So if you want to find the common difference for this range, for this sequence, all you have to do is subtract 2 from 1. So you're going to be having 1 minus 2 and you're going to be getting equal to minus 2. So the only thing there is that your common difference in this one is going to be a negative number instead of a positive number. So the only difference again is that you're going to be getting a negative number instead of a positive number. So 1 minus 2 here should be minus 1. And another thing about common difference is that you can use any of the values. It doesn't have to be the first term and the second term. What matters is that you have to be making use of the consecutive values, the ones that are following each other. For instance, here, I can decide not to use 2 and 1 to find the common difference. I can do minus 1 minus 0, and I'm still going to get minus 1. I can as well do minus 2 minus 1, and I'm still going to get minus 1. So you can make use of any of the terms in the sequence as long as it is the two terms following each other. I hope you understand that. Now I'm going to be moving over to the nth term of an AP, that is an arithmetic progression. Now the nth term of an arithmetic progression, nth term of an AP, is simply represented as Tn. Now, the nth term of an arithmetic progression is simply that particular term in a sequence which you've not been given. Maybe as you have this sequence, this is the first term, this is the second term, this is the third term, this is the fourth term. And now maybe you are asked to find the 15th term. So that 15th term there is an nth term when you don't know the value. So you can just be given that 10 is the nth term of this sequence. Now find n, something of that nature. Now let me show you how to derive the formula for this nth term of an AP. Now you know that in an arithmetic progression, the first term is A. A here is our first term. And the second term is going to be our first term plus the common difference. Now let me use this for an example. My first term here now is A. And to get this second term, all I had to do was add the common difference, which is 2, to this first term, and I get this. To get this third term, all I had to do is add 2 to this second term, and I'll get this. Now, what it means is that if my first term is A, my second term is going to be A plus D. And then my third term is going to be this second term here, which is A plus D, added to another common difference. And with this now, I'm going to be having A plus 2D. So my third term here is going to be A plus 2D. And my fourth term is going to be A plus 3D. And so on and so forth. So if I should follow this particular way, it means that my nth term here is, okay, let me just not rush over to it. Let me explain it in details to avoid confusion. Now, if I want to find my nth term, if you observe here, you're going to see that this here is my first term, this here is my second term, this here is my third term, this here is the fourth term. And this third term here is simply 2 multiplied to the common difference. This fourth term here is simply 3 multiplied to the common difference added to the first term. So if you notice, you will see that the position of each of the term simply has one number less multiplied to the common difference and added to the first term. So it means that if I want to find the nth term in this particular sequence, all I have to do is A plus n minus 1 multiplied by D, where n here is going to be the position of that term in the sequence, minus 1 multiplied by the common difference added to the first term. So this here is simply the formula for finding the nth term in a sequence. So we're having that Tn is equal to A plus n minus 1 D. And this is the formula to find the nth term of any progression, as long as it is an arithmetic progression, any sequence in arithmetic progression. Okay, let me solve a question under this arithmetic progression to clarify us, to avoid mistakes. Because most times in mathematics, you feel like you've understood the topic, but when you're given a question to solve, you see that you've actually not grasped that topic properly. So let me solve maybe one or two examples. Now I have a question here. The question says, the nth term of an AP is Tn equal to 5n minus 17. And we are asked to find the third term, fourth term, and fifth term of the AP. So I believe that from the explanations that I've given previously, that we must be able to solve these questions without finding it difficult. Now we've already been given the formula or the equation to find the nth term in this particular arithmetic progression, and we are told that it is Tn is equal to 5n minus 17. Now for the third term here, it means that our n is equal to 3. So wherever I see my n, I'm going to replace it with 3. So for this one, I'm going to be having that T3 is equal to 5 into 3 minus 17. And I'm having 5 times 3 here is 15. 15 minus 17 is equal to minus 2. So my T3 here, or my third term here, is minus 2. Now for the fourth term, my n will be 4, and I'm having T4 is equal to 5 into 4 minus 17. And this is giving me 20 minus 17. And this is equal to 3. Now for the last one, which is the fifth term, I'm going to be having that T5 is equal to 5 into 5 minus 17. 5 into 5 here is 25. 25 minus 17 is equal to 8. So this is my third term, this is my fourth term, and this is my fifth term. I hope you understood this question properly. Now I have another question here. The question says, find n if 206 is the nth term of 6, 10, 14, ... So the question says, find n if 206 is the nth term of 6, 10, 14, and so on. Now we already know that to find the nth term, I'm going to be having a plus n minus 1 d. And now from what we are given here, our a is the first term, and the first term here is 6. So I'm having that my a is equal to 6. And then my d here is the common difference. And to find the difference, all I have to do is subtract 6 from 10. And I'm getting 4. So my common difference here is 4. And remember, if you are given a sequence of number and you are not certain if it is actually an arithmetic progression, all you have to do is find the common difference using 2 or 3 different values. So if I'm not sure if this sequence that I'm giving is an arithmetic progression, all I have to do is find the d, which I already did, and then find it again using another set of numbers. So for the second one, I'll be doing 14 minus 10. So if you get the same answer, it means that yes, the sequence of numbers that you're given is actually an arithmetic progression. So what we have here is truly an arithmetic progression. Now that we've confirmed that, and we've found our a and found our d, but we don't know the value of n, and the question also says that the nth term is 206, so our Tn here is going to be equal to 206. So if I substitute all of this into this formula, I'm going to be having that 206 is equal to a, which is 6, plus, I don't know the value of my n, so I'm going to write that back, minus 1, then my d, which is 4. So now if I open the bracket, I'm going to be having 206 is equal to 6 plus n multiplied by 4 is 4n, minus 1 multiplied by 4 is minus 4. I'm going to be collecting like terms, and I'm having that 4n is equal to 206 minus 6 plus 4. I hope you understood what I did here. Or let me just go quietly. So for this, I'm going to be having 6 plus 4n minus 4 equals to 206. So I left this 4n here and then moved the rest over. When 6 comes over to this side, it becomes minus 6. And when minus 4 crosses over, it becomes plus 4. So I'm having that 4n is equal to 206 minus 6 is 200. And 200 plus 4 is 204. So now I'm going to be dividing by the coefficient of the unknown, which is n. So if I divide here by 4, I will divide here by 4. 4 here will cancel out 4. And I'm having that my n is equal to 4 here is 1. And 4 into 2 cannot go. 4 into 20 is 5. And 4 into 4 is 1. So I'm getting 51. So I'm having that my n is 51. So it means that 206 here is the 51st term of this arithmetic progression. So if you continue adding the common difference, which is 4, into these values, when you get to the 51st term, you are going to be getting 206. Please, if this is your first time coming across my video, I give well-detailed explanations of topics in mathematics. And also I solve questions, both from past questions and from textbooks, and also recommended questions. So if you found this helpful, please make sure to like, share, and subscribe. And also stay tuned for my next video.